7.6, segments in circles. So first we're going to go over a couple vocab words that we've already learned, and then we are going to learn a new vocab word. So the first vocab word we need to review is chord. Chord is a segment with both endpoints on a circle. Okay. The next vocab word we have is tangent, which is a line that intersects a circle at exactly one point. And our new word is called secant, okay, which is a line that intersects a circle at 2 points. Okay, so again, we have our chord, which is a segment with both endpoints on a circle. Tangent, which is a line that intersects a circle at exactly 1 point. And secant, which is a line that intersects a circle at 2 points. And as you can see below, I have different scenarios where those could be applied to a circle. And with each of these scenarios, we're going to have a different formula that we use to solve those different situations. Okay, so for the first situation, we have 2 chords. Okay, so I'm going to go ahead and label these chords. So this is going to be A, this will be B, this is going to go ahead and be C, and this will be D. Okay. It doesn't matter what part is what section is lettered what section, in the sense that you could pick anything, but it does matter which ones go together. So A and B are obviously together, and C and D are together. So in order to solve when you have 2 chords, when you're missing a part, you're going to multiply A times B and set it equal to C times D. Okay, so in other words, you're going to multiply one part of a chord to the other part of the chord and set it equal to the other section of the other chord to the other section of that chord. Okay, so 2 chords, AB times CD. Okay, 2 tangents. Okay, remember tangents where it intersects the circle at 1 point. It touches at 1 point. I'm going to label this A and this B. Okay, and we've already talked about tangents, but to remind you that it would be A equals B. Tangents are equal to each other. Okay, now our new vocab word, secant. And this is a line that intersects at 2 points. So it intersects here and here and here and here for the other one. Okay, now for secants, it's a little bit more difficult because we have to think about 2 different parts of our secant. So we have what we call the outside. Okay, so I'm going to color this top one. That's going to be our outside. I'm going to label A as our outside. And then we have this outside. Okay, so there's 2 different outsides. Now there's also 2 different total lengths. There's the total length of that secant. Which I'm going to call x. And then there's the total length of the other secant, which I'm going to label y. Okay, so again, to refresh, we have outsides, a and b, and we have total length, x and y. And so in order to solve for a secant, you will multiply the outside of one secant to its entire length and set it equal to the outside of the other secant to its total length. And then last but not least, we have one tangent and one secant, okay? The secant touches really close to the edge, okay? And so it is very similar to combining what we know about tangent and secant. It is slightly different, but similar. So this is our tangent, so I'm going to label that with T. And then again, we have our outside of our secant. And we have our total length. So this one is slightly different, and so it won't just be set equal to each other. It'll actually be the tangent squared equals a times x. Okay, and so these are the vocab and the formulas that we will be using for today's lesson.